Okay, we need to talk about solving linear inequalities and reporting the solution to those equations. Okay, an inequality is different from an equality, an equation, because I don't have an equal sign anymore. I've got one of the other four possible symbols here. You know, less than, greater than, less than or equal to, or greater than or equal to. Okay, I'm going to have one of those four symbols instead of the equal sign. Otherwise, it's going to look very similar. Okay, but if you think about it, you know, if I say x equals 3, I mean, that's it, baby. There's one answer, x equals 3. But if I say x is less than 3, I'm talking about a lot of numbers, aren't I? I mean, how many numbers are there less than 3? Well, it goes from anything just right on the other side of 3 all the way back to negative infinity. All those numbers would fall into the category of negative 3. Okay, if we look, I'm going to pull up pages from a book here. It'd be a lot easier to see, maybe. If we look here, x is less than 3. If we wanted to represent those on a number line, well, 3 itself is not included, and here's where there's a difference between a square bracket and a parenthesis. You see there's a little parenthesis on 3 here. That means 3 is not included. Otherwise, everything is shaded to the left, all the way back to negative infinity. Okay, part B says x is greater than or equal to negative 1. I just want to make sure you can see this okay. Let that zoom in for a second. Alright, I think it's okay. X is greater than or equal to negative 1. Well, at negative 1, there's a square bracket. That means it's included. All the greater than numbers are shaded. C here is in between a couple things. It's, if you look at it from x's perspective, you kind of read it backward. X is greater than negative 1 if you read it backwards. Now read it this way. X is less than or equal to 3. So x is greater than negative 1 and less than or equal to 3. And if you look at this third line, there's a parenthesis at negative 1. That means it's not included. There's a square bracket at 3. It means it is included. Okay? Now there was a question on one of those practice exams very similar to this part C, but then it said identify either the whole numbers or the integers in this range here. Okay, and if you look at that range there, negative 1 would not be included. So the only whole numbers or integers would be 0, 1, 2, and 3 in this case. Okay, and like I said, there was a question on one of those practice exams where it gave you a kind of a range like that, and it asked you to identify the integers in that range. So watch out for if it doesn't have the or equal, which this one doesn't, it's strictly greater than, negative 1 would not be included. Okay, only 0, 1, 2, and 3 would be included. Okay. Alright, so a couple other ways to represent that stuff. First is called interval notation. Now, if I wanted to show all numbers from negative infinity up to 3, but not including 3, I would show it like that. Infinity is a figure 8 on its side, so negative infinity is a negative figure 8 on its side, up to the number 3, but a parenthesis means I don't include the 3. Okay, so that's how I would show x is less than 3. Okay? How would I show the next one? X is greater than or equal to negative 1. And it doesn't do that for us. Shame on that. Well, I'll do it then. X is greater than or equal to negative 1. How would I show that in interval notation? Well, I'm going to have my number line here. I'm going to have negative 1 on the number line. And I'm going to have a square bracket. A square bracket. And everything to the right of that square bracket gets a nice shading. Okay? Greater than or equal to negative 1. Okay? It's kind of messy for me to draw right there. This last one, how would I show that in interval notation? Well, negative 1. Let me just write it. How would I show this in the interval notation? Well, negative 1's not included, so it's going to be negative 1 up to and including 3, and then we put a square bracket on 3. Okay? In that previous example, I noticed I just drew the graph instead of doing the interval notation. What was I thinking? The interval notation on this one would be square bracket at negative 1 all the way up to infinity. The infinities always get a parentheses, but the numbers sometimes get a bracket and sometimes get a parentheses. If the number is included, it gets a bracket. If it's not included, it gets a parentheses as far as the number goes. Okay. Alright, so inequalities are kind of reported a little bit different, either in that interval notation, or there's another notation called set builder notation. So I might as well bring the book back and take a peek at that real quick. Okay, if I wanted to show, come on baby, zoom in. If I wanted to show x is greater than some number a, that means I'm going to start at a and go all the way up to infinity. A is not included, so it's a parentheses. Strictly greater than a, not equal to a. Okay? Greater than or equal to a, now a gets a square bracket all the way up to infinity. The infinities always get a parentheses. Okay? I want to show x is less than some number b. Well, less than means I'm going down to negative infinity. So negative infinity all the way up to b, but b is not included, so it gets a parentheses. And finally, x is less than or equal to b, negative infinity all the way up to b, but in this case, b gets a square bracket because it is included. Okay, so we're going to report answers to inequalities that way, because there are a whole range of answers to inequalities. Equations just have a single, unique answer. Inequalities don't. They have a range of answers. Okay, so let me pull up a couple of things here. Otherwise, you're going to see almost identical process. There's one extra thing to look out for. I said this, x plus 8 is less than 12. Solve that. We're going to solve it just like an equation. Subtract 8 from both sides. Subtract 8 from both sides. X is less than 4, right? Well, how do I show all numbers less than 4? Well, less than means I'm going to start way down here at negative infinity. I'm going to go up to 4, and 4 is not included, so I'm going to put a parentheses by my 4. That's how I show all numbers less than 4. Okay, what about this one? What about 4x minus 1 is less than or equal to 3x minus 6? When we're doing inequalities, I always recommend putting x's on the left, okay? So we can just read the answer left to right. It's easier. So let's put the x's on the left. 1x minus 1 is greater than or equal to negative 6. All the mechanics here are the same. There's only going to be one other thing to worry about. X is greater than or equal to negative 5 in this case. How do I show that? Well, greater than means I'm going up to positive infinity. So I'm going to start way down here at negative 5 and work my way up to positive infinity. Okay? Well, negative 5 is included. It gets a square bracket. Infinities always get a parentheses. That's how I would show that in interval notation. Okay? The only time you got to have a little extra whoop-de-doo with an inequality that you need to worry about is when you either multiply through or divide through by a negative number. Okay, let's look at this one. Negative 3x is less than or equal to 21. Okay? I'm going to divide by negative 3. I'm going to divide by negative 3. When I divide through an inequality by a negative number, I have to do the old switcheroo on the inequality symbol. It now becomes a greater than or equal to problem. Negative 7. Okay? See how I switched it? I flipped it around, switched it. The old switcheroo. How do I report that? It's a greater than negative 7 up to infinity. Negative 7 is included. That's how I report it. Okay, so that's the only difference. The answers are reported a little differently, and I may have to switch the inequality, maybe not. Okay, it depends on the situation. All right, let's try this. Let's try this one. 7x plus 15 is greater than or equal to 13x plus 51. Okay, x is on one side, constants on the other. Let's put my x's on the left. I'll get a negative 6x plus 15 is greater than or equal to 51. Okay, subtract the 15 from both sides. Okay, hopefully, I know I'm kind of rifling through this. Hopefully this is pretty quickie at this point, right, on solving this stuff. Negative 6x is greater than or equal to 36. And once again, I'm dividing by a negative number here, so I'm going to say x is less than or equal to negative 6. Okay, how do I show that? Less than means I'm going down to negative infinity, all the way up to negative 6. Infinities always get a parentheses. The numbers sometimes get a parentheses, sometimes a bracket. If the equal part is there, it gets a bracket. If there's no equal part, it just gets the parentheses. Okay? Alright, that's basically it. I don't want to spend too much time on linear inequalities because I don't think you're going to see a whole lot of them. Mostly just the kind of the reading the range of numbers, you know. Again, I remember seeing a problem on one of the exams where it kind of gave you maybe a range that looked something like this. 4 is less than x is less than or equal to 7, something like that. Okay, and it asks you, tell me the whole numbers or the integers that fall into this range. And you might be tempted to say, well, 4, 5, 6, and 7, right? Except 4 does not fall into the range because x is strictly greater than 4. So 4 is no good. So only 5, 6, and 7. And usually when we're listing a set of numbers just like that, we put them in the curly Q braces. Okay, so you might see curly Q braces with things in it like that, and that's okay. That's how we would just list a set of numbers that fall into the category. So the integers that fall into that range in this case would be 5, 6, and 7. Why is 7 included? Because I've got the or equal part. If it was this, then no, only 5 and 6 make it. 7 doesn't make it either because it's strictly less than 7, strictly greater than 4. 5 and 6 would be the only ones that make it. Okay? Alright, that's inequalities in a quickie nutshell.